Greetings, welcome to Self-Assessment 5, Problem 3. So in this application problem, we're saying one 12-ounce can of Dr. Pepper contains 39.4 milligrams of caffeine. The function a of x equals to 39.4 times 0.8341 raised to the x power gives the amount of caffeine remaining in the body x hours after drinking a can of Dr. Pepper. Answer in complete sentences. Okay, so part A. How much caffeine is in the body 8 hours after drinking one can of Dr. Pepper? Show all of your work and write your answer as a complete sentence. Round your answer to 2 decimal places as needed. Okay, so our function a of x is being evaluated at 8. In other words, we know this 8 right here is telling us that x is equal to 8. So a of 8 is equal to 39.4 times 0.8341 raised to the 8th power. So we're going to go ahead and get that onto our calculator. Let's go ahead and bring that up here. And we'll go ahead and use our calculator to actually do this computation. So we're going to take 39.4 parentheses 0.8341 when we're going to raise that to the 8th power. Hit and enter, and it tells us that we're going to have roughly 9.23 milligrams of caffeine left in our body. So a of 8 equal to 9.23, make sure my decimal points there, milligrams, which tells us that if we were to give our answer in a complete sentence, is that after 8 hours, there is 9.23 milligrams of caffeine. Maybe one of the hardest things to do here is how to spell caffeine, right? Okay, all right, so that's part A. Let's go take a look now at part B. So part B of this question, let's see, get to the right window here. There we go. Part B says, again, same problem statement, but this time it says, how long after drinking one can of Dr. Pepper will only 1 milligram of caffeine remain in the body? So now notice they're giving us 1 milligram of caffeine, and what they want to know is how long, all right? So in other words, they're looking for the particular value of x. So the x is equal to what when a of x is equal to 1. So that's very different than the last problem where they gave us the x value when we evaluated. This time they gave us the y value. We want to know the corresponding x value, or our functional value a of x equal to 1. So what that tells us is that we're going to go ahead and solve the equation. 1 equals 39.4 times 0.8341 raised to the x power. Now we don't have the tools at this point to solve this problem algebraically. We will in the not too distant future. In the next lesson we're going to start learning about the tool we need for this, known as the logarithm. But for now we're going to go ahead and solve this using a graphical technique. So to do that, we'll go into our calculator. I'm going to set y1 equal to 1, and then we'll go into y2 and we'll set that equal to 39.4 times 0.8341 raised to the x power, and we will use the intersect routine to see if we can find the point of intersection. So let's go ahead and get the calculator back up here. Let's go ahead and clear out our home screen here. We'll hit our y equals key. Let's clear out y1. Let's go shut that plot off. Just show you, remember, just the quick way to shut a plot off is to go from the y equals menu, highlight the word plot, and toggle the highlighting by hitting your enter key. Okay, so y1, we said we're going to make that equal to 1. And then in y2, we're going to put in 39.4 times 0.8341, close the parentheses, raised to the x power. All right, so, well, let's go and play with our window a little bit, because we know some things up front about the window. Is that we know that the minimum amount of time is going to be 0, so we can start, if you'd like, at say -1, just to give us a little bit to the left of the origin, and then the max, let's go out, let's say 30 hours. That's over a day, so feeling pretty good that hopefully I've got all the caffeine out of me after a day. X scale of 1, that's probably fine. Maybe we'll make it go 5 just so we don't have an axis there. And same thing with the y-axis, is we don't have negative, we will have no negative amount of, we don't have any anti-caffeine in our bodies, but a -1 will be good to start with. And we know the beginning amount of caffeine was basically 40 milligrams, so we can put in 40 milligrams for our beginning or our starting value of y. Okay, so now if we press graph, we get the following. All right, now that's a really good graph because it shows us the behavior of the caffeine with respect to time. Let's go ahead and blow this up into the big screen. And it shows us that the caffeine is coming down and decreasing as we expect decaying, and then our point of intersection is going to be somewhere around here. Now that's, like I said, it's a great picture to interpret the situation, but not so great for us to find the point of intersection. So let's go back into our window and let's adjust the y-axis to go from -1 to 2, because that's the only part we're really interested in, is finding out where does the graph actually intersect that horizontal line. There we go. So now we've got a much clearer picture of the point of intersection, which is right here. And notice this is, remember, this exponential, this decaying exponential a of x right here, is the amount of caffeine in the body after x hours. And so we want to find out when that amount of caffeine, what hours is that, does it land on 1 milligram. So remember, we went in units of 5 here, so it's 5, 10, 15, 20. So it looks like right around 20 hours or so we'll be down to 1 milligram. We can do better than that. We can actually go in and use the intersect routine in the calculator and not just guess from our graph. And remember that to do this, we need to define the first curve. We need to define the second curve, which in our case is going to be our exponential. Look at the frog down here, we can see him. And then we got to give the best guess, which is going to get as close to the point of intersection as we can. And we hit an enter, and voila, we weren't too bad guessing 20 hours. It's 20.25 hours if we round off to 2 decimal places. Now, just as a quick aside, for you folks who are using the Graph and Calc 83 on the iPhone, you would do it by actually touching the graph. You use your finger to touch the point of intersection, and that's how you find it. There are really good help menus in that program, but if you need any additional help, please let me know, and I would be glad to do that for you. Okay, so let's go back to our problem here, and let's go ahead and put in a sketch of what we just did. So here is the x-axis, here is the a of x-axis, and we're going to accentuate our graph, just kind of change the scaling a bit to make it so that we can see the whole thing, and we're going to say there's our point of intersection at 20 point, I believe it was 24, let me check real quick. No, 25, my bad, excuse me. 20.25 hours, all right? Remember, x was in hours here, and a of x up here, that's an a of x, that was in milligrams. All right, so it says rounding our answer to 2 decimal places as needed, and we're supposed to give complete sentences for every one of these. So we would say after 20.25 hours, there will be 1 milligram, 1 mg of caffeine in your blood. Caffeine, everybody's favorite drug in America. Okay, cool. All right, well, we've got one more piece of this. We've got to go do part C, so let's go to that. So part C, it says, give the equation of the horizontal asymptote and explain the significance of the horizontal asymptote in this situation. Okay, so as we saw in our calculator, which was one of the reasons we wanted to set our viewing screen so we could see the behavior of this function, is that this is a decaying exponential. It starts up here at around 40, 39.4 to be exact. In other words, we know that this is at 0 by 39.4 is that ordered pair right there. And then the function does the decaying exponential dance. And so it comes down like this, where as the hours go by, we get closer and closer to 0 caffeine in our blood. But that said, it never ever gets there, because mathematically, we know that the x-axis here is playing starring role of a horizontal asymptote. As a matter of fact, the equation of that horizontal asymptote we know is y is equal to 0. So what does that mean or explain the significance in this particular situation? Well, it says that mathematically, or math-wise, you have to let x go to infinity. And one way of stating that is you write an x with an arrow pointed towards infinity to get to 0 milligrams of caffeine. That's to get a of x to approach 0. And so what that tells us is that mathematically is that you have to be careful, is that the model has artifacts to it that don't make sense in reality, because we just saw after 20 hours we're down to 1 milligram, and the reality is probably after about 24 hours you'll be gone completely, no more caffeine left, or just such small amounts they'll be undetectable after that point. So I'll let you go ahead. I'm going to leave that sentence for you as for you to interpret. I don't want you just coming up with what I write down. And that takes care of problem 3, and we'll see you back here for the next self-assessment.